Today we're going to continue a refactor I started a while back converting an old Visual Basic project to modern C#.NET Core. The application we will be refactoring is an engineering tool used by RF engineers to analyze frequencies on a SmithChart. Don't worry about what all that means. This isn't a hardware engineering workshop. Instead, you'll see some true legacy code, stuff I wrote many years back. We will work to get it converted into a stronger architecture over the coming months. My name is Justin Colson of SparkPoint University. If you're new, please subscribe and like this video. Let's refactor. So let's get started. I have two folders. I have legacy and I have libraries. My legacy stuff is my VB stuff. It's stuff I've had for 10 plus years. Not very pretty code. It works, but it's not the best. It's kind of in my wild years of programming. And then down below I have some libraries that I've started to refactor and rework some of this code. So why don't we hit play and show you what this application does. Remember, this is an RF engineering tool, so that means radio frequencies. That implies, basically, well, I say implies, but it really is used for engineers that work with Wi-Fi, circuits. They work with cell phone circuits. They work for satellite circuits. They work with anything that kind of has a signal is typically what an RF engineer or a microwave engineer would work on. The goal of this application is that we're going to import some data, and we want to get all the lines of all the lines that you see on this graph here in a minute into the center of this dot. So why don't we import, and then I'll explain as we go. Let's import some S parameter data, which stands for scattering parameters. Now I'm going to import this ADL8150 device. It's an analog device. I believe it's a low noise amplifier. I can preview this import parameter, which is S11. And it goes from 10 megahertz, I believe, to about 40 gigahertz, which is pretty way up there. So we'll import, and there we go. So you see, this is the S11 parameter, the reflection coefficient of this device. Now, you can see there's a lot of little dots in here that, or a lot of little lines. This red is very close to the center, which is good, right? But there's a lot of stuff on the outside here too that's not close to the center. So these are different frequencies. So I can add a marker here, and we'll just do a 500. And that's almost dead in the center, but I can come out here, and 21 gigahertz has a reflection coefficient of 16 dB, minus 16 dB. What that means is that you're going to lose that much power at 21 gigahertz when you use this device, meaning that much power is going to be reflected back from the device before even going through it. Not good. So we want to maybe try to get this closer. So what we can do is we can use these components. Basically, I can add a capacitor in parallel with the device, shunt, they call that a shunt, and see if I can get it closer, right? Well, no, I do that and it moves further away, so we don't want to do that. Why don't we try a series inductor? And let's not use that frequency. Let's use a different matching frequency. Let's use something like 31 gigahertz. We'll do 31 gigahertz. Let's see if we can match on that. There we go. See, I can move this around. So if I add this inductor, it will change the shape of my frequency response. Now, this requires a 137 picohenry inductor, which is super small. You can't really buy those off the shelf. But that's kind of what this application does, right? I can start adding components, and I can do, this is a transmission line. I can basically rotate it. Let's rotate it here. Then I can do it maybe another inductor. Maybe try to tighten it up a little bit, kind of like this. And there we go. See, it's a little bit tighter. Not great, but it is a little bit tighter. And I can continue to do this over and over again until I get the frequency response I want. And I can hit view circuit here, and I can see that the source, here's the source, this is the input. I have an inductor that's 100 picohenries, and I have a transmission line that's 125 degrees. And I have another inductor that's 137 picohenries. And then this is the device we're testing. So if I put this circuit in place, ideally, then I would be able to get this frequency response. Now, there's more to it than that, of course. We're not going to go through everything. But that's the purpose of this application, is to really help the RF engineer. There are other aspects of this application as well. I can enable history. I can change the impedance. I can do shadow data. I can do constant Q circles, Bizwar circles. I can adjust the aspect ratio. I can insert other types of components. I have special components like series transmission lines. I have resonant circuits and parasitic elements. There's also a good number of options that I put in here a long time ago. You can see connect points, draw lines. I can show data points if I wanted to, or maybe just mark the first frequency. And maybe we'll do that. We'll just show you how that works. Let's do some blue in here. We'll get rid of some of that. Do a pink one. Okay, shadow data. Won't worry about that. Some tools, history, numerical options. I can do it in degrees. I can do it in radians. I can have precision, dB. There's a lot of different options that this thing allows us to do. And I can also use a predefined image. And that's the image we're using. I can also have it draw custom. It doesn't look as nice to me, but we'll show you just for the fun of it. There we go. And you can see down here, my first mark is actually marked here. This is how the application works. So what we want to do is jump into the code. So just to kind of give you an idea, we can look at some of this code. We'll go to the main form just to kind of show you what that looks like. And yes, here it is. Good old Visual Basic. I haven't used this language in a while, but I still kind of roughly know what it means. You can see here that, you know, back then it was kind of more of that Hungarian notation where you kind of have M for private, and then you might have IMG for images, and, you know, FRM for forms, and TXT and PCT, you know, all these different things we do back in the day. But that's kind of a legacy style now. And you can kind of see here I have all my events in here, and I have my functions. I have these if statements with all the code kind of bunched together. I'm not even reusing code in most places. Yeah, like some of this stuff is repeated multiple times throughout the code base. There's a lot of calculations. You can see there's lots. And then I can go to something maybe a little bit more specific, like the parasitics. Let's take a look at this. Ooh, look at that. I'm using a good old case statement with an enum. These days I use interfaces. So you can see that I've changed a lot in the way I've done things. Like this is actually not the best way to approach this problem. Not anymore. So these are some things we want to fix, right? We want to fix some of these aspects of it. We want to get rid of some of these select statements that maybe aren't necessary. We want to handle like this message handling. We want to put a lot of this stuff maybe in services that we can reuse maybe on other UIs in the future. These if statements that are one-liners, you know, do this, then exit sub, exit. Like we could really do this a very different way. So we're going to fix this up. So where do we start, right? Well, we don't want to start at the main point, the central point of the application, which is FRM main and all these forms. That doesn't sound wise. We want to kind of start at the edge of the application. And the way I typically do that is I want to try to cut away as much of the application I can from the old stuff. So like here, error handler. Let's look at that. Network parameter exception, I got a C error, and I got a C warning. So where are all these used? What I think we should try to do is just get rid of one of these first. So let's start with C error. We're going to go here, and I'm going to find all my references. Let's hope it's not a lot. There's a good number of them, but it's not the end of the world. I think we can make this work. So why don't we do this? Why don't we take this method, and now I could use a converter online or something like that, but we're not going to do that. What we're going to do is, there's not that many lines of code here to worry about. We're going to redo our error message the way we want to. And in fact, maybe we should go see how it's actually being used. So let's see, we're creating an error here. And what are we doing with this error? Nothing. We're doing nothing with the error. And basically we're raising an event, even worse. Okay, so where is this coming from? Find all references. We have a handler in here on FRM main, so we have one handler. Okay, so this is important. So now we know where our errors are being changed and where they're being cleared. And it's in one spot. So I'm going to pin this. We're going to hold it here. And let's go back. Basically, as soon as this creates an error, it raises an unchanged event. I'm not sure I'm real happy about that. So let's think for a minute. How do we want to fix this problem? Now, I think the reason this is it's created a central error mechanism that we can kind of reuse. I'm not against that logically. I just think that we don't want to handle it this way. Instead, we want to have a service, right? We want to create a service of some kind. So maybe what we'll do is we will create a new library, and we'll just call it our error handling library. And for now, I will make it specific to the SmithChart program. I will actually not try to make it super generic because that could add a lot of complexity up front. So let's create a new project. And let's do a class library. And we're going to call this SmithChart dot error handling. Okay, we'll go next. And we don't want to use .NET Core yet because these VB applications are not that new. So why don't we do .NET Standard? I don't think we need to do anything greater than that. And let's create something that's going to kind of mimic this a little bit. So I'm going to come in here and we're going to create an interface. First thing we're going to do is create a error handling service. So we're going to go error handler. Okay. And what do we want it to do? So we want it to take an error in, right? We want it to take a number. It says I use a number here. I'm not sure why I'm using a number. Let's see what kind of numbers I have. See these numbers, that's kind of a legacy way of performing things. We really could just use different exceptions. But we'll get to that one step at a time. So we'll keep the numbers. So why don't we do this? Let's pull this over. And it's not gonna like it. That's okay. So we're gonna say public enum, and we're gonna say error code. And we're gonna put this in here. All right, we're gonna have a problem. All right, let's format this up. Okay, so we have our error codes back. So we need to take in an error. Yep, we'll take in the error. And then what else we need to do? We need to take in a message, the module it came from, the routine it came from. Interesting. So let's actually find all references again, see kind of how this is being used. So import S parameters, export touchstone, import touchstone. And then, yeah, we're doing a lot of this manually. See, I don't know that we need a lot of this. Instead, the line number would be important here. You know, knowing where exactly it came from. That's really what this is. This is logging. That's what we're really talking about. We're talking about logging. And let's see what happens when we actually do that on change event. So this handler here, errors change. What actually happens? We show errors on the screen. Okay. Let's go back here. And let's not worry about the import, export S parameters just yet. We'll do the method name though. We will take care of that. So what we're gonna do is we're gonna say, okay, void handle error. We're gonna say error code. Even though I think we're gonna get rid of that, we're gonna say message. And then we're going to include call it target. Target being, you know, where did this error occur, that the target that it occurred, or maybe the source. Maybe the source is better. We'll just use a source. We'll use a single string for that. I don't think we need more than that. So we have our handler now, okay. But see, we need to get notified of an error occurred. So let's just create an event, and I think what we'll do is we'll just create an event arg here. So we'll say error occurred event args. All right. Public error code. Do a getter here. And we'll do an internal set for now. And we'll do public string source. We'll do the same. And then we'll make sure that we pass in this information as we create the event args. Well, no, I don't think we need to do that, right? I think really we'll just add the message as well. So why don't we just do that? We'll just say message get set. There we go. And everybody's happy. So then what we can do, we'll fix up our naming a little bit. We'll say event, and we'll say event handler error event log. Look at that. Isn't that nice? Okay, got it real close. There we go. Something we can attach to. I think we still need that for now. We'll have to think of another way to approach that maybe later on. But for now, we have our code right here. We don't really need a whole lot else. We do need an implementation though. So let's create a default implementation. We're going to say public class default error handler. What we'll do is we'll go ahead and just keep it simple, and we'll go invoke, and we'll just do this is what's sending it, and we're going to do a new event args, and we'll just code equals code, message equals message, source equals source. I'd like this to throw an error if we do have a problem. We need to have a message. So let's just throw an error if something goes wrong here. Right, we'll do the same thing for the source. We want to make sure we have both of these. Provide that guarantee to the application. Okay, so here we go. We have our default error handler. Doesn't do a whole lot, just basically invokes the exception. Now we could create a logging one or something like that, so that way, you know, it can log it to a file maybe later on. That's why we're creating the interface to begin with, is so we can use that decorator pattern we discussed in previous videos. So let's move this out for now. We'll leave this alone for now. We'll leave it here. There's reasons why I like to leave this stuff in place. Not what I meant to do. Not what I meant to do. Let's come back. Rename file. There we go. And we need to delete this one. Okay, so now that we have our error handler, we can go back to here. So LVL errors.visible equals true. Who is editing this? Final references. Errors occurred. It's not really useful, is it? How's errors click? And what does it do? Shows a dialog, shows form errors. Well, let's go to here. Oh, it's getting back the current errors as well. So you see, we actually have to be able to clear these errors out. But see, I think this is a concern for the UI, and it shouldn't really be a concern for other aspects of the code. So I think we need to think about the architecture here a little bit. So to be able to show these errors later, we need to have this information. I think we need to adjust our error handler a little bit. So we have our handle, code, message, source. We have an error occurred. All that does is allows us to show something on the screen, but we want to make sure that we can clear as well. So why don't we do that? Let's add a clear errors. And then we'll also do we need a model for this. That's what we're missing. I was hoping to avoid the model, but it looks like we're going to have the model. Why don't we just go ahead and create it? See, I'm starting to think that an exception makes more sense to use. We probably should have used to begin with. I'm at the point now where I think we need to just move it to an exception. Because of the complexity that we're starting to jump into with show errors, I mean, why do we have all this? Why not just show the details? If we're going to show the details, this should be pretty straightforward. So we have rows, button cleared. Yeah, this doesn't make sense to do this way. So instead of doing, we'll still keep the error handler, but instead, all we'll do is we'll have an exception here. And we'll just say clear exceptions. And we will rename this exception handler. Rename this. Okay. Means we don't even need error codes anymore. So let's get rid of that. Let's change this to add, because I think add makes more sense now, because really not what we're talking about. And now is it really a handle anymore? Not really. It's really just it's an exception collection, right? That's really what this is. So let's rename this to something a little bit more functional here. So exception collection. Great. Error occurred. Let's rename that. Let's say error added. Oh, actually exception added. Let's do exception added. Okay. Add clear. I think now that we know it's a collection, let's just do clear here. Man, it seems like I'm doing a lot of work, right? You can see that I'm redoing a lot of stuff that collection already has. Why don't we just do this? Why don't we inherit from collection? I'll just do exception. So let's look at what this has on it. It may have almost everything we need. Add, clear, contains, copy to, remove. This is perfect. Like, why changes? We can add, clear, remove. I mean, you know, the count, everything. So let's just get rid of this. And we're going to get rid of this. We will keep the exception added. I think that makes a lot of sense because we want to know when that occurs, right? We can even have a when it's cleared. Maybe that's a good thing to do because it does seem like we have, let's say event args, have that use case. And for that reason, we're going to change this to, instead of exception occurred, we're going to call this an exception collect exception events. We'll even add an event handler. We won't do removed. I was thinking we'd add removed, but I don't think that makes sense right now. This is a lot easier to deal with now. Why don't we go back to default error handler, because this is no longer correct. Say I exception collection. Get rid of all this. Okay, we will use a list, but we'll use a list as a private backing field here. So we'll say read only list of exception. So when we create a new one, let's do public default exception collection. I'm not even sure that's what I want to call it yet. So we'll just leave it alone for a minute. There we go. And we'll make this easy. We're going to say collection dot count is read only, false. Put those together. Clear. Okay, when things are cleared, we need to call on exceptions cleared. Okay. On add, we want to say that an item was added. So let's say on exception added item. Perfect. So I think the only thing we might want to consider is that when you remove the last item, then maybe we say it's been cleared. So yeah, let's change this back to brackets, and let's get the count. So say constant. That's not how constants work. Nothing in JavaScript. Constants. Current count equals. You know what? If count greater than 0, we'll just jump out. Return false, as nothing was removed. Not what I meant to do. Equals 0. Return false. Now we're going to try to remove it. So collection dot remove. I'm going to call this results. If count now equals 0, we're going to basically say on collection cleared, on exceptions cleared. Just in case somebody removes them manually, it'll show that cleared, clear out those messages on the UI. So when it goes back to empty, maybe that's what we should rename this. Maybe on exceptions emptied. I like that better. Emptied. So that, I think that has a little more meaning. Then we're going to return the result that we got from removing. Let's go up here. We're going to have to go back here if I want to rename this to emptied. We'll say exceptions emptied. Back here, this should have been renamed. It was. Great. And we have ourselves a little default here. Now, the benefit of creating this interface was we've added some new functionality to the collection, right? So I come back to here and you can see that, I could have almost just used this, but the benefit of having these is that I can now use this collection interface to maybe if I want to intercept with a decorator pattern or some other pattern of injection. Maybe I want to inject a static collection everywhere I go. I can use that interface. So I think I like this. I think this will work for me. I do need to rename the file because the file is not named right anymore. Perfect. Okay, we have our collection now. I think we need to go back to here. I think we have everything we care about. Unchanged. Cleared. Okay, so why don't we do this next? Let's go into our main and let's create this service. But we want to keep it somewhat global, which is going to be a problem. I don't like using global variables. It's always risky. But I think it's necessary at least for the refactoring process until we can figure out a better way. Got past that. Now we want to make sure that this gets created. All right, we want to do a shared sub new. Put that here. There we go. This is required by the designer. That's fine. And any initialization, so we're going to say exceptions is going to equal to new default exception collection. And I don't need that. We have our new. I think we need a regular sub new. Yeah, see, we need to have a regular sub new. This is actually not necessary here. So we'll just go ahead and create both of these just to be safe. So now that we have these, we can properly set up our callbacks. So let's go back to here. And we'll find our references again, just to make sure we find it quickly. Here they are. We have this one. And we have this one. So what we're going to do is we're going to add a handler for exceptions dot exception added. And we're going to have to use a lambda statement here. So we're going to say lambda sender as object. Actually, this only needs to be a routine, so we'll do a sub. And it's going to be E as exception event args. Okay, we'll just do it here. So in this case, what we'll do when it's added, we're going to say LBL errors dot visible equals true. All right, add handler, emptied. LBL errors dot visible equals false. Okay, so just to be clear and make sure that this is how we wanted to do it, we're going to jump up to errors changed. LBL errors visible equals true and cleared false. So let's get rid of these. We have no need for them anymore. Perfect. Okay, so then scroll back down. Here we are. Almost get past you. And these are now, we can make these go away. Perfect. Basically, we're going to show the label when we have errors, and we're going to hide it when we don't. Okay, so now we have our exceptions. Okay, so let's start removing some of the other pieces. Who else is talking to him? So we have our FRM errors. Here we go, show errors. See, I think we need to inject here. I'll go over functions, show dialog is error. Show dialog, this will show all errors. And we really need to inject, I think, somehow. Actually, I don't think we need to inject anything here. What we'll do is we'll use the global from the FRM main, which should always be open. So that's what we'll do. So what we'll do is we'll leave this in place. We'll work on our table now. Let's look at our table, show errors, see error count, add errors to the table. Okay, so let's come down to here. And let's look at our rows. This is a data table. It's a data grid view. So let's go look at that. Error code, message module occurred, routine occurred. So what we'll do is we'll just separate this out a little differently. Type is probably, so the type is whether it's an error or warning. So we need to make sure we maintain that. However, I think the rest of this we can get rid of. What we'll do is we'll just do an exception, just like this. There we go. Not much different. While we're at it, why don't we go ahead and go back to FRM main. Go ahead and add a public shared warnings as exception collection. Do a very similar thing. We're just going to say warnings equals new default exception collection. Might be a better name for this. Just don't have it yet. Okay. At this point, we'll basically just delete this. Put this here. Say warnings. Warnings. Warning. These are awfully similar. I could make this a little bit better, but we're going to be getting rid of all this VB code at some point anyway, so why waste the time on it? So the last thing we need to do is to make sure that all of our references to C error is gone. It's not. We still have these. So why don't we do this? Let's fix this logic up. If has both, clear errors. Otherwise, do that. If is error, clear errors. Okay, so I think I have some logic up here. If I pass in this is error, and to be clear, it has both. So we'll do that, right? Do this, clean that up a little bit. Okay. Has both. And at this point, why don't we just do the clear this first? And then we'll just return. It's not return, it's exits up. Okay, now we actually just need to clear them out, which these are not the right ones to clear out. So we're going to say frm main dot exceptions dot clear. Frm main dot warnings dot clear. And we'll refactor this as well. Pull this out. Okay, better. So now we've gotten rid of all traces of the C warnings and the C errors from here. This does not look like it's being used, so let's might as well just go ahead and get rid of anything that's not being used. Done. So let's go back to FR main and let's make sure that we fix up our warnings. So we did this down here for the exceptions. That's fine, but where we want this to be warnings now. We're going to have to address this because, warnings dot exception added doesn't make sense, right? So maybe what we should do is just rename this while we're here, because I called it exception collection, but maybe that is an exception collection. So why don't we just rename this though to added? And we'll just rename this to emptied. It might make it a little easier to read back in FRM main. So warnings added, warnings emptied. I like that. Then we'll have LBL warnings and LBL warnings. And just make sure we didn't screw anything up there. Warnings visible. Perfect. So we'll delete this. And we will make sure that it's all good down here. Okay, let's save that. Now, where else do we have? So we fixed up our show errors. How about this? So now we have some issues. We have our error numbers. We actually have an exception. We can actually just take that exception directly. That might even be better. But we are doing some catching here. So I think we'll be okay. Throwing. We're still using the E error numbers. We want to fix that at some point. But for now, I think we might be good to go if we just use our service. Now we're gonna have to get it in here, which means we're still gonna have to call FRM main directly, which I do not like, but we will use a dependency injection at a later date. So we're just gonna go add, and we're just gonna say add this exception. Now, what is this error occurred? So we need to get rid of this as well. So I'm not a big fan of how this is looking here. So why don't we make this a little bit easier to read? If error count or warning count is greater than 0. Well, let's mimic it, I guess. So we're going to say our main.exceptions.count is greater than 0. If our main.accept warnings count is greater than 0, then we'll do this and actually show the exceptions right away. Okay. We also have this one where it's a warning. So why don't we go ahead and just do this one, which will be same as before. Actually, this is a different area. Let's go back up to what we were doing before. See, I'm not a big fan of how this works. We really want to, these are the exact same try catches. Well, minus this, but we don't care about that at this point. So why don't we just create But as you can see, we're not really using this error number in any logic anywhere. In the numbers, why do we care that there's a number to begin with? So I think what we want to do is we're going to want to refactor these exceptions out, and so we'll do that here in a minute. So to fix these errors and to get rid of these numbers, we'll end up moving these exceptions out directly. That'll be important. We actually will probably move it into our new DLL we just created. And adding that in there, we can actually create some static methods to kind of remove these as these magic strings and make it a little more reusable. We won't do that yet, though. Let's get rid of some of these other issues we have with our primary class, which is C error. So let's look again. Let's see what else we have left. So I'm about to remove it and just see if we can drop it all together. So we have some new ones here. And this is a little tougher because this is actually sitting in a whole different project. So this means that for us to be able to do this, I'm going to have to actually inject that service into this S parameters. The reality is that we shouldn't be doing this here anyways. We should really just be throwing an exception. But we're returning nothing for a reason. So why don't we see where this is being used before we go off and make any drastic changes? Because throwing an exception really does change things. Well, this is one of our this is wrapped up, so this is on our wrapped up try catch we created. So it would catch if we threw an exception. That's good. This one's wrapped as well. This one is not. He's not here. It's not. Where is he being called from? This is where it starts getting tricky. You have to really keep up. Looks like we're doing it in a couple different places. And not everything's wrapped up. So that does pose a risk by throwing an exception. We could really break the code in several places. Reality is we should have on pretty much any event that a user is clicking on should have try catches wrapped up. This is to prevent things like this from happening. This is how bad this code is. I guess I got lazy back in the day and decided not to do try catches everywhere. Not doing it this way. I mean, this is just bad. So what we're going to do instead is we're going to throw new network parameter exception. And we will get rid of this. Won't need return nothing anymore. We're going to go back and we're going to look at our C error one more time. There's a few more. We are just going to rethrow network parameter exception because I don't know what's in here. So we'll play it safe. I'll throw new network parameter exception. And the message is going to be, can you do this? And we're going to have an error code, the EX error number. And we're going to say EX.message space line EX.line number space file name. There we go. Get rid of this. We're going to copy this down. The difference here, we do not have a line number from the exception anymore. And so we're just going to do this here. And it's going to be the system error. Yeah, he is not liking this fun code, is he? It's okay. We have the same thing down here, or at least similar. We have warnings. These exceptions I think we can pass through because all we're doing is message and message. We're not adding any new information to the exception. So what I'm going to do instead is I'm actually going to get rid of these exceptions because they'll just funnel right through. But of course, we may have a problem when we actually go to do the export itself. So let's just see if these are wrapped up. We only have one spot, but this is a different, this is a form. These are modules. Okay. Let's see where he goes to. And he has the exception. So what we're going to do is we're going to do a try catch here. And we're going to say if it is an exception, actually we're going to say if it's one of those warning exceptions. So network parameter warning exception, we're going to say warnings dot add EX. Otherwise, we're going to catch EX as exception. And we're going to say errors, oops, exceptions dot add. There we go. And we'll go ahead and protect ourselves. This is a pretty easy one to protect ourselves on, so we'll just go ahead and do that. Perfect. Now, we will save everything. We're going to close down a few of these items. Let's get rid of this. We'll go back to see error. Let's check one more time. We should be really close to getting rid of all of these. And everything else is inside of itself. So, in theory, I can remove this from the project. It's excluded. And we're going to try to build, and our e-numbers is now becoming a problem. But that's okay. I think that's perfectly acceptable. We need to fix that anyways. So there's 83 of them. Oh, this is not going to be fun. So I think we're going to speed this up and fast forward on this section of the code. Okay, so we're gonna slow back down for a second and we're gonna look at this. I mean, we are not reusing code very well. So I think we need to take a quick look at this refactoring. So let's see how close they are together. So we have file name, please enter file name to preview. Preview, this is the preview one. Let's go to the import. Import frequencies, we're using a lot of the same logic here. It's almost the exact same. And then we're pulling back the scattering parameters, parsing those parameters, we're simplifying. Make sure that's true. So scatter, scatter, narrow frequency range. We're just doing it at a different step, it looks like. So at the very least, we could get up to this point for the import touchstone. We can put this into its own method. So I think that's what we need to do. We need to make it so that we can get this back. So we're just going to what is this type? M scattering S parameters. Let's just return this. We're going to say private function S parameters as S parameters. All right, and then we're going to reuse this code. So we're going to go to the one I've already fixed, this one, and we're going to go from here. And we're going to copy this down and see what we're missing. And instead of this, we're just going to return. Okay. And nothing. What are we missing? Looks like everything just works. Simplify that down. Okay, so then what we can do is actually I can get rid of pretty much, oh, you know what? The import, we want to change that from import to preview. So we'll just say, we can have that done. These are all the same. I think we're good. Now I can get rid of CT param. I import it from here. So we can, for now, we're going to go do this. M scattering must be a field on it. Okay, so that's fine. So we'll say M scattering is going to equal to load S parameters. Import type is going to be import. And we don't have F start or F stop now. Put these back up top. And do they really need to be by ref? No, because we're not changing. Well, no, we are changing them. This can be changed here. Yeah. We better. All right, so that's going to be passed in. So let's do the same up here. Basically going to move these up, above. Then we're going to basically just do this. I'm going to say dim t scat as S parameters is equal to load S parameters, and the import type is preview, F start, F stop. There we go. Okay, so we reuse the code. Perfect. Not perfect, but I mean, I say it's perfect. It's better than it was. At least we're not having to redo all that work multiple times. All right, this will be something we have to do in another round, but I think all the exceptions are good here. So let's go back to our references. Go to our error list. We better do a build because I'm pretty sure we have more errors than that. Frequency is not defined. Why is frequency not defined? Because these are all in older frameworks. Let's get these all caught up. Yes. Make sure this, I think, is the one I changed. Yep. I'll upgrade plotting as well. No. 472. just for the sake of building, we'll go ahead and do this one, even though we're dropping this assembly soon. Perfect. Let's build again. Build failed, but we're actually really close. We can drop this network exception because we have a new one now. So we'll drop this one. We still have this issue with this warning number being the same, which is weird. I'm not sure why I would be storing that warning number when I'm using a different one. That's a mistake in the old code. So what we're going to do is we're going to replace that here. We're going to come here as well, and this is warning. This actually should be this. Let's see if we build. There it is. Now we're failing a little more, according to what I expected. Okay, so we're now on our modules. Let's import this for now. We'll probably undo that at some point. And let's keep on creating. So we're going to speed back up, and I'm going to continue creating and fixing all these exceptions. All right, so we have successfully got rid of our primary exception. See, errors is gone now. That's good news. And we pulled all of it into this single exceptions table. That way, or exceptions module, I apologize. And now we can see all of our exceptions in one place. We can refactor these as we need to without actually affecting the code or having to go to individual code lines. And we can reuse them if it's, there's a good use case. So the next one we got to do is see warning. Same concept. We're going to find out how many of these warnings we have around town. Not many. That's good news. But we probably have a good number of these. And not many there. So we're going to speed up again while I fix up the warnings the same way we did the errors. Have this error handler is a log. It's actually a logging class meant to track behind the scenes. It looks like it runs it against the log.txt. Some default time formats and post log. We have some private routines. See, in a case like this, it makes the most sense to just reuse .NET. And I'm trying to see if there's anything I really want to do here. And I think we'll just use iLogger for this. There's no reason to do this. So how do I want to implement that? What I think I'll do here is this is general, this is under modules, the primary project. Instead of using this, we will actually use iLogger. So let's do public log as iLogger. Let's see if it finds it for us. It does. References. Looks like we only do this in a few spots, which is good. So what we'll do instead is we'll abstract this out a little bit. So we'll come to here and we'll actually make sure in here we actually log from this location instead. So we're going to go public sub log message, make it a little bit more informative here. Post just doesn't make sense. We'll just post a message. Of course, I got to do it right because I'm back in VB. Great. We'll say log information. We'll say message, and we're going to be done because it looks like all we're doing is messages. We don't need the extra functionality. Now, because of the way this is working, we need to instantiate this the first time we do it. So if log is nothing, then we need to instantiate it. So what we're going to do is I think we're going to use Serilog. That one makes the most sense to me. So let's add a reference. And we'll close this down. And we're going to maybe do another method here. We'll do a function, private function, create logger as iLogger. we'll put this here. So we'll say log equals create logger. Perfect. Okay, so we have Serilog now. We want to import it. So we'll say imports Serilog. Great. And let's try to create a logger. So we want to basically we need to set up log dot, oops. Oh, it's not going to work. So Serilog log dot logger. Will be equal to new logger configuration. Dot, oops. Dot enrich from log context dot write to console. And we're gonna do dot file, right? So we want to do dot file. And we're gonna have to do some put some information in here. So we'll hard code this to the log.text. And we'll have it roll every day. In this actually, I think, because okay, it's cool. There we go. Great. And we're going to say create logger. Everybody's happy here. There we go. I'll make this a little bit better. Okay. And now we need to create our iLogger. Gem factory equals new. Okay, we'll just use the default values here. And we're going to return factory dot create logger. And the category name, we're going to just use SmithChart. There we go. It is ambiguous. So we'll do this one. This one's ambiguous as well. There we go. We create the logger. If it's null, and then we will just log the information. Then we got to go fix up our other pieces here. So instead of post log, we're just going to say log message. Okay. Log message. And we'll go here and just a log message as well. All right. So now what we want to do is let's just remove this as well. And let's build. All right. I'm going to open up this folder. We're going to completely remove it here in a second. I'm going to remove. I don't want to keep the code. So since I don't want to keep the code, we will actually delete this whole folder. Perfect. And save. Let's hit play, make sure everything still works. And it looks like it does. Let's try importing because that was one of the big pieces that we fixed up. Parameters, preview. Preview still seems to work. Import. Oh, look at that. It does still seem to work. Let's do 10 gig. Yeah, look at that. Let's do it right there. Seems to still work. So that concludes this video. I hope this refactoring session has taught you a few things about how to refactor and work from the outside in. We worked from a very simple error handling VB DLL, and we moved that into a new C# error handling DLL. where we fixed up some of the architecture just a little bit. There's still more work to be done, and hopefully that's helped. Hopefully you see kind of the process that I went through, how I looked at references and how I removed them from the actual project, rebuilt a few times, and really checked it out. I did make some alterations to the naming conventions. I did change some of the errors as I went through it because I found some issues with the naming, but that's expected during a refactor. Of course, I did a quick test at the end to make sure that I didn't break anything too big. We do still have some issues with try catches, so if errors do occur, we might run into some issues, but we will fix that down the road. Thanks for watching. Don't forget to subscribe and like this video, and I'll see you next time.